Alright guys, let's talk about what happens when we have powers of different trig functions. Again, this is part 3 of our tackling of trigonometric integration. We've done sine, cosine, all the cases for them, and now we're going to have a look at powers of other trig functions. So let's take an example of, by the way, the remaining that we have are tangent and secant. The remaining trig functions that we have to look are tangent and secant. So let's have a look at a formula that you guys need to memorize or keep noted down in your notebook. Tangent squared plus 1 equals to secant square. Okay, this can, if you subtract the negative or the 1 both sides, so you're going to have tangent squared theta equals secant squared theta minus 1. Okay, so you can also have both of those. Now let's talk about how we could use these formulas and within the cases when we could use these formulas. Say we're given the problem to find integral of tangent cube theta d theta. Okay, again, remember, when we see powers of trig functions and we're told to find an integral, that should be alarming. Okay, we do not want, we do not like to see the powers, guys. We would like to see things in to the power of 1. Okay, so let's have a look how we can reduce this. Okay, and bring it down to 1. And if you were been watching my previous videos, you can see how we've been plugging in formulas, to make our work kind of easy. Okay, so cube. Okay, so tangent is cube. What are we gonna do? We are going to split it. Tangent square theta times tangent theta d theta. Okay, this is gonna be equal to, so tangent square theta can be written as 1 minus. If you look at this formula over here, we can write that down as 1 minus, secant square. My bad. It can be written as secant square theta minus 1 and tangent theta times tangent theta. Okay? Okay, and d theta, not to forget d theta. Okay? Now if we multiply, okay, multiply into the inside, this is going to be secant square theta tan theta minus tan minus 10. And where did the cursor go? Cursor, please come back. Oh, tan theta d theta. Okay. Okay. Now what we could do is let u equal. Then we could do u sub now. Okay. We could let u equal to tan theta. Okay. And du, as we know, the derivative of tangent is secant squared theta. Okay. D theta, of course. And what we could do now here is do the u sub. So we could write it, we can do, we take the integral of two separate, okay? Let's break this one big integral into two separate integrals, because that's something legally we can do, okay? Of course, d theta to both of them. And then secant square, again, that's our du. We can plug that in as our du, and tangent is our u. So it's going to just be d theta. Okay, sorry, du, right? Not to be confused with what we had. So u du. Okay, minus integral of what is tangent? Tangent can also be written as sine over cosine, right, guys? Cosine theta. Okay, so that's what we're going to do over here. Okay, so we could just take the integral of u, using our normal power rule. So it's going to be u squared over 2 minus, now what we're going to do over here is we're going to introduce another u sub. Since we already used u, we're going to use w. Okay, so let's let w equal to cosine theta dw would be equal to negative sine theta d theta. That's a derivative of cosine. Okay? What we could do now is do the u sub. Okay, so sub that in, so sine theta and w for that. D theta, I'm gonna sub in d theta. D theta is cursor. Where d theta is gonna be equal to dw, negative dw over sine theta. Okay, so d theta is equal to negative dw. So the negative is going to come outside. So when the negative comes outside, this is going to turn into positive. Okay, guys? And we're just going to be left with dw over sine theta. And it's going to cross it out. We're going to cross that out. So we're going to be left with u squared over 2 plus integral of dw over w. Okay, guys? So next step, u squared. What was our u? Tangent theta. Then theta squared over 2 plus, and we know if we get dw over w, we should think of natural log. It's going to be natural log of w plus c. Then that alarm should go off. Oh, that looks something like du over u. Okay, so that's what we're going to do over here. So we're going to do natural log of w plus c. Okay, almost done. Please move up. Okay, so we could just, oh, so it's going to be tangent theta square over 2 plus natural log of cosine theta, because that was our w, right? And plus c. Alright guys, that's our final answer. Alright, now let's see what happens when we have secant, okay? And let's take kind of like a tricky problem. So let's say we're given the problem to find the integral of secant to the fourth of natural log of theta over theta. Okay, d theta. Okay, now as you guys seen, we split. We've been splitting all this while, and we're gonna do the same thing over here. We're gonna split this into secant square natural log of theta. Yeah, that doesn't look good, right? Times secant square natural log of theta over theta, d theta, not to forget d theta. Okay, so what is secant square theta equal to? Let's go back up. That equals to secant squared theta, tan squared theta plus 1. Okay, that's what secant squared theta equals to. Now we go back, if my page allows me to. If my cursor, oh, there you are. Now go down. Back to where we were. Okay, tan squared, so that equals to tan squared. Now we just don't have theta, we have natural log, right? So that's going to be equal to tan squared of natural log theta plus 1 times secant square. Let's just let the second one be secant square natural log of theta d theta over theta. Okay, now secant square. Now what we could do is let we're gonna do u sub now. Our favorite time to do u sub. U sub, so we could do u equals natural log of theta. Du is going to be equal to 1 over theta. Remember, the derivative of natural log of x is 1 over x dx. In this case, it's going to be d theta. Okay, so d theta is going to be equal to theta, cursor, please come back, cursor. Okay, there it is. So theta du. Okay, so theta du. Okay, so we can sub that in for d theta. Now let's go back. So we said our u is natural log of theta. So when we do the u sub, it's going to be natural log of u plus 1 times secant square of theta d theta over. Now remember, what is our d theta? Our d theta we said was theta times du, right? So it's just going to be one more small, it's tiny mistake. We got to put u over here because that's our u sub, right? So theta times theta du. Okay, so we cross out the thetas. What are we left with? Tan square u plus 1 times secant square u du. Okay, guys, so that is our answer. Now, if we look at that is, we still have to go. We still have. So what we could do next is we're gonna do w sub now because w sub is better than u sub. Just kidding. That's since we have u sub already, we're gonna do w sub. W sub. Let's do w equals tan u. Okay, tan of u. Okay, and so dw is equal to the derivative of tangent is secant square u du. Okay, so what is our next step gonna look like? So we're gonna do the u sub for tangent. So it's gonna be u squared plus 1 times. Well, look at that. That kind of looks like what we have, right? So I'm gonna let du, sorry, yeah, du equal to um, dw over secant square. So I want to show you how that cancels out. Okay, so times secant square u du is equal to, as we said, it's equal to dw. Please come back. Okay, dw times dw over secant square u. Okay, that's gonna be. Now we're gonna cross it out. Okay, but now look at that. We're left with u squared plus 1 integral of u squared plus 1, and we know that using the power rule, it's gonna be u cubed over u cubed over. Oh wait, we got to do we sub? Remember, this was not just u; it was w, guys. We cannot make that mistake. Remember, we're gonna sub in whatever it was. So it was w squared. And here also, and here it was u though, right? It was just that one place where we had to make sure that was tangent that we were subbing, not natural log, right? So that could cause problems. That could definitely cause problems. So let me erase this and put it where it was. See, we got to make sure of these mistakes when you're trying to solve these problems, especially when you're having double u sub. Okay, when you're doing u sub twice, right? So that you got to make sure you don't make these types of mistakes. So it's gonna be w squared plus 1. Cursor, come back, please. Cursor, please come back. Okay, plus 1. Okay, and dw, right? So we're going to do the power rule, w cubed over q, 3 plus w plus c. Do not forget the constant of integration. Let's plug in whatever our w was. Our w was tangent of u. Okay, now we know tangent of u. What was u? U was natural log, right? So of natural log of theta cubed over 3 plus tangent of natural log of theta plus c. Okay, guys, so that is our final answer. If you did like this video, please do like, share, and subscribe. If you have any questions, please leave them down in the comments. Any specific questions about trigonometric integration, please leave them down. And I hope you did gain a firm understanding of trigonometric integration and how you sub in values to solve these types of questions. Thank you so much, and I hope you have a great rest of your day. Bye.